If y is equal to e to the power of x minus y, show that dy dx is equal to this. Okay. So we start with given y is equal to e to the power of x minus y. Now you see e has been raised to the power of x minus y. You can differentiate directly or you can take logs. Okay. I will show you both ways. Suppose I differentiate directly. So therefore dy dx is equal to ddx of e to the power of x minus y is equal to, first you will differentiate e to get e to the power of x minus y and then differentiate the power of ddx of x minus y, which is e to the power of x minus y into ddx of x minus ddx of y, okay, which is equal to e to the power of x minus y into 1 minus dy dx. Okay, so now I'll multiply everything with e to the power of x minus y minus e to the power of x minus y dy dx. Okay, that means, but what is e to the power of x minus y? E to the power of x minus y is, okay, but I'll just do that later. So we get this. Now we collect the dy dx together. What have we got here? We have got dy dx is equal to e to the power of x minus y minus e to the power of x minus y dy dx. So if I now take the dy dx on one side, so we get dy dx plus e to the power of x minus y dy dx is equal to e to the power of x minus y. Okay. Now what you do is you take dy dx common, 1 plus e to the power of x minus y dy dx is equal to e to the power of x minus y. Therefore, what is dy dx? E to the power of x minus y divided by 1 plus e to the power of x minus y. Now see what you have to prove here. You have to prove that dy dx is equal to y by 1 plus y. And what have we got here? Dy dx is equal to e to the power of x minus y by 1 plus e to the power of x minus y. What do you see? What is e to the power of x minus y? E to the power of x minus y is y. So you put the value here. E to the power of x minus y is y divided by 1 plus y, which is proved. Any questions?
No, sir.
Now this was first method. Now how do we do by logarithms? So you have given, you have y is equal to e to the power of x minus y. You take log on both sides. Log y is equal to log e to the power of x minus y, which is log y is equal to, now x minus y can be taken as multiplication, log e. And I told you what is the value of log e? The value of log e is 1. So you simply get log y is equal to x minus y. Now I differentiate both sides with respect to x. Differentiating both sides with respect to x. You get ddx of log y is equal to ddx of x minus y. Means you're differentiating log y with respect to x. So you get 1 by y dy dx is equal to, this is ddx of x minus ddx of y, which is dy dx. That means 1 by y dy dx, ddx of x is 1 and ddx of y is dy dx. Now you collect the dy dx together. 1 by y dy dx plus dy dx is equal to 1. Take dy dx common, you get 1 by y plus 1 dy dx is equal to 1. That means dy dx is 1 by y plus 1. Now you take the LCM, y 1 plus y. This means this is y by 1 plus, which you had to prove. Yes, so I've done it both ways.
Yes, sir.
So this problem you can do both ways, because at the base you had an e here. Okay, you never actually had a function. Okay, that is why I could do. But if it was, say, something like x square minus x to the power of x minus y, then you could have only done this way. Okay, you could not have done this way. Understood? Because e exactly is not a function of x. So when a function of x is raised to the power of another function of x, then we apply logarithms. So e is exactly not a function of x. You don't have a function of x at the base. Okay, so let us see the next one. The next one is, if, question is, if x to the power of m, y to the power of n is equal to x plus y to the power of m plus n, prove that dy dx is equal to y by x. Okay, this is what you have to prove. Do you simply dy dx is equal to y by x. Now remember, here x has been raised to a power of a rational number. Y has also been raised to a power of a rational number. M and n here are nothing but rational numbers. Okay, x has not been raised to the power of any function. Okay, you can differentiate directly again here, or you can take logs. Okay, let me show you both ways. Let's see. So you have given x to the power of m, y to the power of n is equal to x plus y to the power of m plus n. So differentiating both sides, implicit functions, remember, differentiating both sides with respect to x, we get ddx x to the power of m, y to the power of n is equal to ddx x plus y to the power of m plus n. Okay, that means I will differentiate this by u into v rule, y to the power of n ddx x to the power of m plus x to the power of m ddx y to the power of n is equal to, what will this be? First we'll differentiate the power, nx to the power of n minus 1 m plus n into x plus y to the power of m plus n minus 1 into the ddx of x plus y. Okay. Next is y to the power of n. Now differentiate x to the power of m, mx to the power of m minus 1 plus x to the power of m into ny to the power of n minus 1 is equal to m plus n x plus y to the power of m plus n minus 1 into ddx of x is 1 plus dy dx. Right? In the next step, what I will do is I will take, I can write this as y to the power of n, or let's say my to the power of n. I can write this as my to the power of n into x to the power of m divided by x, plus I can write this as n x to the power of m y to the power of n divided by y. Okay, is equal to m plus n x plus y to the power of m plus n divided by x plus y into 1 plus dy dx. Now you can take common x to the power of m, y to the power of n, m by x plus n by y is equal to m plus n into x plus y to the power of m plus n divided by x plus y um, into 1 plus dy dx. Okay. Without log, it actually becomes a little long. In the next step, now see x to the power of what do we have to prove? We have to prove is equal dy dx is equal to y by x only. Okay. Now we know that x to the power of m y to the power of n is x plus y to the power of m plus n. So we simply put it here. X plus y to the power of m plus n. Okay. And you can take the LCM here. Um, can take the LCM here as my plus nx is equal to m plus n x plus y to the power of m plus n by x plus y into 1 plus dy dx. Okay. Next step, you take everything to one side, or what you can do is you can divide. So you get 1 plus dy dx is equal to x plus y to the power of m plus n my plus nx divided by xy. Whole divided by m plus n x plus y to the power of m plus n divided by x plus y. Okay. Now what happens? This cancels. X plus y to the power of m plus n cancels out. So what you actually get only here? You only get my plus nx into m plus n divided by divided by x plus y. Sorry. Divided by m plus n into xy. This is what you get. Okay. And therefore, in the next step, get 1 plus dy dx is equal to, you multiply everything. You get mxy, okay, plus my square plus nx square plus nxy divided by m plus n xy, which is now from these two, this one mxy plus nxy, okay, we can take xy common, and yes, can you hear me?
Yes, sir.
Govinda, you can hear me?
Yes, sir. Yes,
Okay.
sir.
Okay. So now from these two, yes, no, don't take common right now. We got 1 plus dy dx is equal to this. Therefore, dy dx you get is equal to all this. You can multiply the denominator also. Sure. Okay. You can multiply the denominator also to get mxy plus nxy. Okay. And then what you do is nx square plus nxy whole divided by mxy plus nxy minus 1. Okay, now you take the LCM, mxy my square plus nx square plus nxy minus mxy plus nxy whole divided by mxy plus nxy. Okay, so now what you get, you open the brackets, mxy plus my square plus nx square plus nxy minus mxy minus nxy whole divided by mxy plus nxy. Okay, so mxy cancels, and nxy they cancel. Okay, so what you get ultimately here is my square plus nx square divided by m plus n, again taking common, xy. And what you have to prove here, you have to prove dy dx is equal to y by x. Okay. Dy dx is equal to y by x. These two cancel. This is okay. Y. So you get my plus nx into x plus y, m plus nxy. I multiply, I get mxy plus my square plus nx square plus nxy by m plus nxy. And mxy plus my square plus nxy minus 1. This is okay. And mxy plus nxy minus mxy plus nxy both cancel. I get my square plus nx square divided by mxy. This is okay. And dy dx is okay. No problem. Here, then after this, hmm, equal to y by x. So this way, um, equal to hmm, prove that dy dx is equal to y by x. It should come. What is the m plus n here? X plus y to the power of m plus n is yes. X plus hmm, this is x to the power of m y to the power of n. Okay. I will come back to this. Let us proceed the logarithmic. We'll come back to this. So given x to the power of m y to the power of n is equal to x plus y to the power of m plus n. Okay. So taking log on both sides, log x to the power of m y to the power of n is equal to log x plus y to the power of m plus n. That means log x to the power of m log y to the power of n equal to m plus n log x plus y. So this now can be written as m log x plus n log y is equal to m plus n log x plus y. Now differentiating both sides. With respect to x, we get m is a constant. So we'll take out of the differentiation m ddx of log x n is a constant, you can take it out. ddx of log y. M plus n is a constant, you can take it out of the differentiation. M plus n ddx of log x plus y. Now this is m by x, this is n by y dy dx is equal to m plus n ddx of log xy is 1 by x plus y into the differentiation of x plus y. Okay, so that m by x plus n by y dy dx is equal to m plus n by x plus y into, this is ddx of x is 1 and ddx of y is dy dx. Okay, that
Yes,
means
sir.
1 plus dy dx you will get, or take the dy dx together.
Yes, sir.
Take the dy dx together, m by x plus n by y dy dx is equal to m plus n by x plus y plus m plus n by x plus y dy dx. This class is till what time?
So 12:20.
Okay, 7-8 minutes left. Okay, so plus n by y, or let's take the dy dx together.
Yes, sir. 12:20.
So n by y dy dx minus m plus n by x plus y dy dx is equal to m plus n by x plus y minus m by x. Okay, now I can take dy dx common. I'll get n by y minus m plus n by x plus y dy dx is equal to, you can take the LCM here, x into x plus y is your LCM. Okay, so you get m plus n into x minus m into x plus y. Okay, you can take the LCM here also. So you get x plus y into y as your LCM. You get n times x plus y minus m plus n times y dy dx. Now I open the brackets here, mx plus nx minus mx minus my divided by x into x plus y. Okay, so what cancels on the right hand side? Mx cancelling here. Okay, and here I simplify, I get nx plus ny minus my minus ny. So ny cancels here, divided by x plus y into y dy dx is equal to, I have nx minus my divided by x into x plus y. Okay, so in the next step I'll have You have nx minus my. What is left here? Nx minus my divided by y into x plus y dy dx is equal to nx minus my divided by x into x plus y. Now take everything there. Get nx minus my divided by y into x plus y dy dx minus nx minus my by x into x plus y is equal to 0. Now what can you take common from these two? Nx minus my divided by x plus y. You can take common. What are you left with? 1 by y
Yes, sir.
dy dx
dx.
minus 1 by x. Okay. So in the next step, you have either nx minus my equal to 0 or 1 by y, or in fact you can write this also, divided by x plus y equal to 0, or 1 by y dy dx minus 1 by x is equal to 0. That means either nx minus my is equal to 0 or 1 by y dy dx is equal to 1 by x. That means either nx is equal to my or dy dx is equal to y by x. Since nx minus my, nx is not equal to my, hence dy dx is equal to y by x. Which is the required proof? Which was what is required here, isn't it? You needed to prove that dy dx is equal to y by x. Yes, clear or not?
Yes, sir. Yes, sir.
Dy dx is equal to y by x. We have
Yes,
already
sir.
got by taking log. Now I don't understand
Yes,
why I
sir.
was not getting here. Okay, I'll just try and let you know why. But you can do it this way also. Okay,
Okay,
but
sir.
you can do
Okay,
it
sir.
this way also. Okay, taking logs, I could do, but you can do it the other way also. I don't know why, what went wrong here. Okay, but anyway, um, I don't have time left. 12:19. Okay, so what I'll do is I'll continue this day after tomorrow. Tomorrow you don't have any class. Okay,